we went through the general requirements section and kind of looked at the applicability of this code and what it's used for, who it's talking about when it says the contractor, the verification inspector, the contractor's inspector, things like that. Looked at few key definitions and where those actually apply, and then also got into some of the lawyer language and basically the language of, hey, this is not a safety standard. So what we're going to do is we're going to go ahead and bypass the design of welded connections, which is section 2. And we're going to jump right into kind of the meat for the CWI, or the meat for the certified welding inspector, where they live in this document. And I'll say, go ahead and give you a quick tidbit. These 3 sections, pre-qualification, qualification, fabrication, is really where I live in this code. If I'm working to this code on a daily basis, those are my 3 that I'm in quite a bit. If we're starting up a project, I'm living in these 2 sections, pre-qualification and qualification. And as that project progresses and we're actually fabricating goods, I'm living in 5 and sometimes 6, depending on if there's any additional type of inspection procedures required. So we're going to go ahead and jump into section 3, which is the pre-qualification of WPSs. And again, I hope you've welded. I hope you've read the scope of this section, but we're going to read it one more time to kind of take a quick review. Pre-qualification of WPS or welding procedure specifications shall be defined as exempt from the WPS qualification testing required in clause 4. Mouthful. Let's break it down. So what it's saying is, if we do a pre-qualification, or we're doing a pre-qualified WPS, it is exempt from the actual testing that is required in section 4. Okay, that's for WPS, not for welder qualification test, not for anything like that, but the actual testing of the welding procedure specification is exempt. Where we would pick that up is in section 4. Okay. So it says all pre-qualified WPSs shall be written. So that means that we're going to take and we're going to live in this section of code. And then once we choose our proper material, joint design, all of those things, we are going to still have to write a WPS, but we're going to always point back and say that we got it from the pre-qualified section of this code, which is in this particular revision, section 3. So in order for a WPS to be pre-qualified, conformance with all of the applicable requirements of section 3, which clause 3, again, clause is just that another word for section, shall be required. So we have to do everything that this section says if we want it to actually be a pre-qualified WPS. WPSs that do not conform to any one of these requirements of section 3 may be qualified by tests or additional tests in conformance with section 4, which is the qualification section. Again, this is the section where we can basically build that pre-qualified WPS according to their standards, the way they've tested it 1,000 times. And if anything is non-typical or non-standard and it doesn't conform with this section, we have to build it out, from scratch. For convenience, Annex Q lists provisions to be included in a pre-qualified WPS. Okay, Annex Q is going to be at the back of the book. And we see basically lists of provisions to be included in a pre-qualified WPS. So basically things we have to make sure we add there, and which should be addressed in the fabricators or contractors welding program. Fancy word for how they're doing things. Welders, welding operators, and tack welders that use pre-qualified WPSs shall be qualified in conformance with clause 4. So here's performance qualifications. It's saying even if you use a pre-qualified WPS, you still have to test the people, the personnel, the welders, the welding operators, and the tack welders according to section 4, which in this case, section 4 is the qualification section. Moving on to the processes, we look at the pre-qualified processes, and I want you to take note of something here. And this, as long as you use this as a, or kind of keep this in the back of your mind, it's very helpful in determining what can be used for a pre-qualified WPS, or what we can write a pre-qualified WPS for D1.1. So we see it says that the pre-qualified processes that we can use to make these pre-qualified WPSs are of the following: shielded metal arc, submerged arc welding, gas metal arc welding, except for gas metal arc welding -S. Now, if you don't remember what gas metal arc welding -S is, that's short circuit, okay? Typically talk about 3 modes of transfer in gas metal arc. We talk about short circuit, which is what 90% of what you've been doing out here is. We talk about globular transfer, which is basically an improper machine setup. There is some application to it, but it's essentially where the wire is burning back into a glob and then falling off. If you've gotten a lot of spatter on something, you've probably been in that globular type range, low wire feed speed situation. And then we also talk about spray transfer, okay? So right here, it says that the pre-qualified processes are shielded metal arc, submerged arc welding, gas metal arc welding, except for that one we've been doing a lot of, which is really good for, like fabrication shops, some manufacturing, things like that. But for structural, it says that that's not pre-qualified. So that means if we wanted to use short circuit, we would have to build a whole WPS, test it from scratch if we're wanting to use technical short circuit gas metal arc welding. And it says that flux cord arc welding is also considered a pre-qualified process. What are we missing? If you thought TIG welding, you're right. So TIG welding is technically not a pre-qualified process according to this code. Now, code-approved processes, we see that, we've got code-approved processes. We see gas tungsten arc welding right here. We'll jump into that in here in a second, but let's look at the remainder of this definition. So all of those processes which conform to all of the provisions of Clause 3 shall be deemed as pre-qualified and are therefore approved for use without performing a welding procedure specification qualification, which we've also said what qualifies that WPS is actually the procedure qualification record, or that PQR. So what it's saying is all of these processes are approved for use without having to write your own WPS and then qualify it with a procedure qualification record. For WPS pre-qualification, conformance with all of the applicable provisions of Section 3 shall be required. It's a redundancy there. We just read that up in the scope of this section, but it's saying it again. So that means it's important, is you have to meet all of the requirements of Section 3 or you're going to have to do, basically a WPS from scratch. Now, here's where it gets a little bit confusing. Code-approved processes. Doesn't say pre-qualified processes. It says code-approved processes. ESW, which is electro slag welding. EGW, it escapes me. Gas tungsten arc welding and gas metal arc welding, short circuit welding, may be used provided the WPSs are qualified, key term there, in conformance with the requirements of Clause 4. Note that the essential variable limitations in Table 4.5 for gas metal arc shall also apply to gas metal arc welding short circuit. So what it's saying here is before someone even jumps on the bandwagon and says, oh, by reading this statement, they're saying that you can't use gas tungsten arc welding, they put in kind of this random statement here. And you'll see why it's random, is it's not talking anything about pre-qualified. It's not talking about anything to do with this section. It's not talking about making a pre-qualified, WPS or anything. All it's trying to do is answer a question that was posed from the previous article. And when I say article, I'm talking about, an actual line of information here. So it's answering a question from this previous article that many will have. Is gas tungsten arc welding even applicable or approved for this process? It is. It's just saying that if you're wanting to do one of these processes, gas metal arc welding short circuit, gas tungsten arc, electro slag welding, that's going to irritate me. I'm going to have to figure out what EGW is, go back through my books. But if any of those processes want to be used, you're just going to have to go through the hard, long way of actually writing that WPS, proving that WPS with a PQR, and then carrying on to test your welders. Okay? Other welding processes. Other welding processes not covered by these two articles may be used see if I can get it to scroll over here. Provided the WPSs are qualified by applicable tests described in Clause 4. So you can even use, laser beam or electron beam welding, something crazy, but you're going to have to take the proper steps and do the actual longhand version of writing a WPS, proving the WPS, and then testing your people. Okay. 3.2.4, flux core and gas metal arc welding power sources. Flux core and gas metal arc welding that is done with pre-qualified WPS shall be performed using constant voltage power supplies. This one can catch people up a little bit. I've seen it catch a lot of contractors up, and to be honest, I believe that there's been a lot of inspectors that have overlooked this, because when you think of flux core, if you've got a spool-driven, suitcase in any old machine, you can do flux core, right, off of a portable engine-driven machine. But unless that engine-driven machine actually has a constant voltage power supply, technically you cannot perform flux core arc welding with every one of those setups. It would be only the setups that do have a CV setting. So like on the Miller Bobcat, something like that, if it says CCCV, constant current, constant voltage, as long as you've got that, you're fine. But in olden days, you could take something like a Lincoln red face or a Lincoln black face, which would be like an SA200, SA250, and you could hook up a suitcase with it, and you could do CC flux core arc welding. It's not going to be perfect. It's not going to be as consistent as it would be if you had a constant voltage power supply. And in this case, for this code, they've specified that it would not be applicable or could not be used. It has to be, shall be performing using the constant voltage power supply. Okay. 3.3, we get into base metal, filler metal combinations. It says only base metals and filler metals listed in table 3.1 may be used in pre-qualified WPSs. Okay, so only the ones in this particular table, section 3.1, table 3.1, may be used in pre-qualified WPSs. For the qualification of the listed base metals and filler metals, and for base metals and filler metals not listed in table 3.1, see 4.2.1. Okay, so basically if it's not in table 3.1, you're not going to not be able to write a pre-qualified WPS. You're going to have to go the hard way, the old-fashioned way, write a WPS PQR, prove that material and the process, in some cases, will actually work using 4.2.1. It says the base metal and filler metal strength relationships below shall be used in conjunction together with table 3.1 to determine whether matching or undermatching filler metals are required. So basically it says, hey, use this together with table 3.1 to see if you have to pick a lower tensile strength filler metal or you're going to match the tensile strength of the filler metal. Okay, so it says down here, we're going to look at this note. Don't know if it applies, but see table 2.3 and 2.6 to determine the filler metal strength requirements to match or undermatch the base metal strength. The one instance where it's referring us back to table 2, which would be in section 2, which we know is the design of weldments. So there is a couple times you do have to refer back to that. But let's continue on, see kind of what we dive into next here. Engineer's approval for auxiliary attachments. Basically, you can think of that as let's just read it. I think you'll get a little bit better understanding. It's not just the addition of a wire feeder or something like that. It says unlisted materials for auxiliary attachments which fall within the chemical composition range of a steel listed in table 3.1 may be used in a pre-qualified WPS when approved by the engineer. The filler metal and the minimum preheat shall be in conformance with 3.5 based upon the similar material strength and chemical composition. It's basically a clause in here that It's kind of like a spacer or a backing strip, but basically it's saying that you can use it as long as it falls within that chemical composition range. It means that they don't necessarily have to be of the exact same material, even though it's going to refer to it in 3.1 as being the exact same material. So that's a confusing little article there, but it's not something that applies so often that I think you need to be too concerned about it. Minimum preheat and interpass temperature requirements. Again, if we're going to actually have a pre-qualified WPS, we have to abide by all these standards. It says the preheat and interpass temperature shall be sufficient to prevent cracking. Table 3.2 shall be used to determine the minimum preheat and interpass temp for steels listed in this code. So preheat obviously is the preheat treatment of material, bringing it up to a certain temperature most conducive for welding. Interpass is exactly as it sounds, in between passes, the temperature that it has to be maintained at or beneath to prevent cracking. So we'll see that a little bit more in table 3.2. Base metal and thickness combination, the minimum preheat or interpass temperature applied to a joint composed of base metals with different minimum preheats from table 3.2 based on the category and thickness is what they're saying there, shall be the highest of these minimum preheats. So if we take two pieces of material that are suitable to be joined together and one has a higher preheat, we're going to use that same higher preheat on the one of lower preheat requirement. Okay, so basically what this is outlining here in this beginning articles is that for you to have a pre-qualified WPS, you're going to have to play by these rules. They're not just giving you a get out of jail free card or a pass of doing all that extensive testing and everything if you don't play by their rules. That's why you're going to find that there's a lot of requirements here, vertical up welding requirements. You know, it's going to go into, if you're going to play by our rules and not do that extensive amount of testing and proving your own WPS, and you're going to use one of ours, you're going to play by those rules. So like here, it says vertical up welding progression or welding requirements. The progression for all passes in the vertical position welding shall be upward with the following exceptions. Undercut may be repaired vertically down. When tubular products are welded, the progression of vertical welding may be upwards or downwards, but only in the direction for which the welder is qualified. So, you know, it's basically giving you those lanes that you can work in to be able to still claim that you're using a pre-qualified WPS. Single pass groove welds, single pass fillet welds, the proper shielding gases that are pre-qualified or that we are allowed to use. Skewed T-joints, we'll get into that a little bit later on. You know, all this is outlining those requirements to basically utilize this very lucrative system of having a pre-qualified WPS for structural steel and not having to, you know, start from scratch every time you go to a new contractor to perform this work. Okay. So post-weld heat treatment. Let's look at one of these tables. Apologize, guys. It's jumped way far down on me. Here we go. So jumping into table 3.1, all we see here is basically different types of base materials and filler metal combinations for matching strength. What you'll find is we have basically the group classification. We see that all of these materials fall into group 1. And then on the next page here, we have the group classification. All of these materials fall into group 2. As well as these, we have a small section of group 3s and group 4s. Okay, so we have different groups. Here's one thing I want to point out to you. ASTM A36, we see in group 1. ASTM A36, we see in group 2. What's the difference between these two types of material? ASTM A36 in group 1 is less than or equal to 3/4 of an inch. ASTM A36 in group 2 is greater than 3/4 of an inch. But what does that really change? Our KSI is the same, or the amount of tensile strength, about 36, and or the tensile range. The yield point is 36 KSI. The actual tensile strength is 58 to 80 KSI. But what do we see that is actually a requirement? Why are these in two different groups, and how do we use these tables to be able to see what really applies to it? So if we look here, ASTM A36, group 1, less than or equal to 3/4 of an inch, we see that the filler metal requirements for shielded metal arc is E60 series, 70 series, A5.5, that would be E70 series. We see down here that we've now looked at the filler metal requirements for these. For shielded metal arc, everything in group 2, it's closed our range here. It says not only can we not use a 60-10 in this category, but you're going to find that the majority of these is low hydrogen. The 28's not. The 15 is not. 15, 16, 18, 15, 16, 17, 18 are low hydrogen. But you see it just basically closed that requirement for us and kind of restricted our ability there a little bit. Okay, let's see where else that would apply. Let's see here. Category A and Category B, we see that we now have, this separated category, but the table we're using now is not for the actual pre-qualified base and filler metal combinations. It's for the pre-qualified minimum preheat and interpass temperature. This one's kind of important. We see the A36, the generic carbon steel plate we weld on every day out in the shop. It's in both categories again, Category A and Category B. Well, let's look. So we see that with shielded metal arc, with other than low hydrogen electrodes, we see that the thickness, or the thickest part at the point of weld joint, 1/8 to 3/4, the minimum preheat is 32 degrees. And there's a note A there that we're going to have to find. But note A, it says that over 3/4 through 1.5 inches is going to be 150 degrees preheat. Over 1.5 inches through 2.5 inches is 225. Over 2.5 inches is 300 degrees Fahrenheit. Now, let's look at it with low hydrogen electrodes. We see A36 now, same, different, different, and different. So there's actually a less preheat requirement on those same material thickness if we're using A36 with low hydrogen versus something other than low hydrogen. Okay? So again, that gives you basically your preheat categories for pre-qualified WPSs, and you're going to have to match these up whenever you're writing that WPS to determine, okay, the minimum preheat, if over 3/4 of an inch through 1.5 inches, we're going to say 50 degrees if we're using low hydrogen electrodes. If we're not, we're going to have to use this other chart here. Okay? Pre-qualified WPS requirements. Here's the actual requirements that we're going to have to list on our WPS. Even though we're using a pre-qualified WPS, we still have to write it. That was that first section up at the top of, right below the scope. It said that it still has to be documented. It still has to be written down. These are the things that we would include on this. The only advantage of pre-qualified is that we don't have to test it as long as we're conforming with all these rules. WPS variables. If a change in any of these particular things, whether that be process, change of welding process, change of welding position, all of those things for those particular, that process, not a change in amperage, this would be things that would basically make it to where it could make it to where we couldn't use a pre-qualified, or we're going to have to at least document what our ranges are on that. Okay. There's those variables continued. And then we start getting into the pre-qualified joints, the types of joints that can be used and their limitations or ranges. So if I'm doing a single V groove with a backing strip or without a backing strip, we're going to see that it's going to tell us the root opening. It's going to tell us the bevel angle. It's going to tell us basically all of the essential variables. So this would be considered an essential variable for a pre-qualified WPS if we didn't do it this way, or with this angle, or with this root opening, or this root face, or whatnot. We would have to write a WPS and prove it from scratch. Hope that's making sense. Let's come down to a joint that we're all pretty familiar with. You see there's a lot of joints in here that can be considered pre-qualified. Whenever we're writing that pre-qualified procedure, just documenting what we're doing, we're going to include the joint designation of what we're actually saying that is allowed based on our pre-qualified WPS. It's not just going to be a standard, any one of these joints. We're going to have to actually document that joint designation. Okay. So let's see here. Single V groove with a backing right here. So the joint designation here, if we're doing shielded metal arc welding, would be B-U2A. Okay. It says the material thickness is basically unlimited. Whatever material thickness that is needed on that, it's fine with that. The root opening is going to be for shielded metal arc is either going to be 1/4, 3/8, or 1/2 inch root opening. The groove angle for 1/4 inch is going to be 45 degrees. For 3/8 it's 30 degrees. For 1/2 inch it's 20 degrees. The allowed welding positions for that particular joint is going to be all for the 1/4 inch root opening, flat vertical and overhead for the 3/8 root opening, and flat vertical and overhead for the 1/2 inch root opening. That's just depending on what material thicknesses that we're using, which one of those is going to be applicable, as well as which one is going to be the least amount of prep. Okay, so that's one reason why there's these differences here. You see the detailed tolerances. Root opening in this case could be +1/16 or -0. As fit up +1/4, -1/16. That means actually as welded. You can look that up in 313.1. But this is where we're actually going to determine whether a pre-qualified WPS, if we're choosing a process that is pre-qualified, such as shielded metal arc welding, we're make sure that our material is a pre-qualified material, that we've documented all of its preheat, post-weld heat, things like that requirements, and we find the particular geometry that's going to make it to where we can complete this project. This is basically what we're assembling together to determine whether we can use a pre-qualified WPS or not. So again, all of those joint details are quite extensive. There's tremendous amount of pre-qualified joints as long as you do it their way. That's why they put all of these joint designations as well as actual limitations on the groove preparation. So for the most part, if you go to work for a company and they're doing all structural steel work or a majority of structural steel work, and they're qualifying their people and their processes and their procedures, most of the time you can get away with doing a pre-qualified. Now, if we were doing gas tungsten arc or something like that, obviously we already determined that that was not a pre-qualified process. So we would have to start that from scratch. But you see there's a lot of material here that they've given to us to basically ease that workload of having to write a WPS from scratch. And really what it does, and on top of it, making it to where there's not as much, work, what they've really tried to do is for the generic everyday things, they've tried to make a system or put a system in place that is easier than actually writing it yourself, to where there can really begin to be more of a standard of this work. We know if we test all those processes and, positions, things like that, if we did it the hard way, we know that it's correct. But at the same time, if we can make it to where the process and the procedure and the work is completed more in a standardized format, that's just going to help, for those what if situations, if something did happen or it wasn't designed or it was designed or not designed correctly. So, guys, I hope this has been helpful to you. We're going to spend a little bit more time in section 3, the pre-qualified section, on our next time back. I think that's going to be, this is really fulfilling the obligation of the lecture for January 28th. I'm going to see you guys back in person on January the 2nd. Or February the 2nd, I apologize. And we're going to answer any questions that you may have in regards to this section, as well as kind of look at section 4, the qualification section in this revision, and see where we get an overlap between these two. So again, what we've done today is we've looked at what a pre-qualified WPS consists of. Next week, we'll actually look at a pre-qualified WPS that's been documented, wrote down, and in conformance with this code. And then we're going to migrate into the qualification section, where we're actually going to look at qualifying people, but then also the longhand way, if for some reason we needed to perform something that was not pre-qualified. So I hope that was helpful to you all. Again, the biggest thing that you can do to kind of prepare you for some of the upcoming assignments for D1.1 is to get into this section as well as section 4, familiarize yourself with it, start to try to understand those relationships, and really that beginning text throughout this section, that first 5 or 6 pages, if you at least skim over those, try to familiarize yourself with both the terminology as well as how this section stands out compared to others. I think that will best equip you. And other than that, guys, looking forward to seeing you on Tuesday the 2nd, and we'll jump back into this a little bit more in depth. Thank you, everybody, and have a good week.